Hey everyone, Rex here again with TorchPrep. I'm in test 3, problem number 52. So, what I want you to do before we dive back into this math test is pause this video, go to your red books, test 3, number 52, read this question. When you're ready, press play. Okay, so we're still in these word problems. You can skip these and wait to the work portion. This one's a little bit more difficult, and I suggest that you probably skip it the first time, go back through it later. It is the last question asking us about this table, about the floor plans of these storage spaces. This one's asking something a little bit more complicated though. So we're going to use our word problem strategy. Step 1 is always, what are we trying to find? We're trying to find which expression represents the size of storage X. It's a potential storage space that they might create if they use the same pattern represented here. So for step 2, we always ask, what do we already know? I just wrote C table. All the information necessary is here on our table. Now we have to start breaking down what is the pattern represented here. So each of these can be represented by their area. So the first one, the area, is going to be 16. The next one, oh, I'm sorry, I jumped the gun. First one, the area is going to be 8, then 16. The third one's going to be 32, then 64, and finally 128. You can multiply all of these dimensions together in your calculator or by hand to get the area of each of the floor plans. Now, each of these things I'm going to represent in a different way. And as I looked through all of them, I'm going to start with the relationship between these two. Really, 8 is 8 times 1. 16, I noticed, was 8 times 2. 32 was 8 times 4. And I started to notice these are getting exponentially bigger, aren't they? And then 64 becomes 8 times 8. So whatever it's being multiplied by is doubling every single time. It has an exponential relationship to represent the area of each storage space. But what I notice is I need a consistent way of writing this. 8 is consistent. Now I realized that 2 and 4 can go into one another. So what I decided to do is represent it like this. This is really 8 times 2 squared. And remember, any whole number is really that whole number to the first power. Also, if this is just 8 times 1, I can turn this into 2 to 0, because that always, anything to the 0 power equals 1. And then look, I found the same pattern, but instead of exponentially doubling, the exponents go up 2 to the, and the exponents raise 1 every single time. Now, I had 8 there. That is 2 to the 3rd. Now, 128 would then be 2 to the 4. So what I see here is a pattern of this variable, the x, is going to be these exponents here, isn't it? Going to be those exponents there. And I notice that each exponent is 1 minus the size number, isn't it? Every single time. So I realize that I can represent this as 8 times 2 to the x, whatever storage number we have, minus 1. Now that's still a little bit too complicated. More complicated than the answer choices that they gave you for this question, isn't it? So I'm going to try to break this down even further. I want to just have one base, one whole number, and then exponents above it. And it's good that I have 2 whole numbers I'm dealing with, 8 and 2. They're going to pretty much do that easily for me. Because remember, 8 is really 2 to the 3rd. So it's 2 to the 3rd is the same thing as 8 times 2 the x minus 1. Now what I'm going to get here is we're not going to be multiplying these exponents together. What we're going to be doing is adding them all together. So we're not doing 3 times x and 3 times negative 1. We have 2 to the x, and then 3 minus 1 equals positive 2. Our representation of the relationship of the area of every single one can be expressed by 2 to the x plus 2. Great job.